Okay, the next example we're going to do is we're going to use our half-angle identities to solve an equation on the interval from 0 to 2 pi. So we look at our equation, we have 2 sine squared of a half angle plus cosine of x equals 1 minus sine of x. So what we're going to do is we're going to apply our half-angle identity, and we're going to replace this half angle with its proper substitution. So it's going to be 2 times. Now it's the sine of a half an angle, and the sine of a half an angle is going to be equivalent to, and making sure I have the right one, the square root of 1 minus the cosine of x all over 2. Now that's the replacement for it, but we were supposed to take that value and square it since it was a sine squared. So I just squared the half angle identity. That plus the cosine of x is supposed to equal 1 plus sine of x. So then the next thing we're going to do is we're going to square. And as you know, squaring a square root will undo that. So we'll end up with 2 times 1 minus the cosine of x all over 2 plus x cosine of x equals 1 plus sine of x. The next thing we'll do is we'll reduce the 2's. We'll have 1 minus the cosine of x plus the cosine of x equals plus, get that correct, 1 plus sine of x. And then what we'll do is we'll collect our like terms. So it's 1 equals 1 plus sine of x. And then the 1's will reduce if we bring a 1 over. 0 equals sine of x. Which means we're looking for an angle whose sine value is 0. Now there's only a few locations where your sine values are equal to 0. So you think about your unit circle. Sine values are 0 at 0 and at pi. So we want 0, and then we're going to wrap around just a half a way around. So x is going to equal, starting at 0, then we have to add on just pi times n. And realistically, all we need for our solution then, every time we go another pi units, we back to 0. So x is equal to pi n could be our final solution strategy for it.